Hello friends, I am Dr. Sudhan Sharma from School of Computer and Information Sciences, Indira Gandhi National Open University. And today's session is about linear programming, and this session is an introductory session. And we are at the point where we are going to touch upon the last unit of this course. That is the last unit of block number 4, and which is linear programming. Before starting the session, I reiterate that in this course or in every course of computer science, you will find that the understanding of previous units is applicable onto the subsequent units. Over here, we are going to apply the understanding of the concepts of the inequalities, and inequalities were covered when we were discussing about the algebra. Algebra 1 and algebra 2 were the two blocks of starting blocks of this course. The last unit of block 2 relates to inequalities, and at that time when we were discussing about inequalities, I emphasized that the understanding of inequalities will be applicable to the concepts of the linear programming. Now it is time to apply the concepts of inequalities to understand what linear programming is. So, to begin with, the objectives of the today's session are to understand the terms like objective function, constraint, feasible region, feasible solution, optimal solution, and what linear programming is. Apart from this, in this session you are going to understand how to draw the feasible region and obtain the optimal solution. Now, to begin with, it is very important to firstly understand that what linear programming is. And linear programming is actually an optimization technique which is really applicable to the real life problems. And in order to understand this statement that what is linear programming, it is better to start with an example, which is a real life example wherein a furniture manufacturing company is manufacturing some chairs and tables, and that means these two are the products X and Y, such that the chairs contributes to the profit of rupees 20 and tables contribute to the profit of rupees 30. And these two products, that is chairs and tables, are manufactured on 3 machines M1, M2 and M3. And the production time of chair requires 3 hours, 5 hours and 2 hours on machine M1, M2 and M3 respectively. That means chair can be manufactured in 3 hours on machine M1, and it takes 5 hours to get it manufactured on machine M2, and thereafter if we go for machine M3, then only 2 hours are required to manufacture a chair. Similarly, the table can be manufactured in 3 hours, 2 hours and 6 hours on machine M1, M2 and M3 respectively. Further, we are having a constraint that M1, that is machine M1, can work only for 36 hours per week, whereas M2 and M3 can work for 50 hours and 60 hours per week. Under such situation, we need to find how many chairs and how many tables should be manufactured per week to maximize the profits. Now, this is a real world problem wherein we are having some objective. The objective is to maximize the profits, and the profit is given that it is rupees 20 for per unit of a chair and rupees 30 for per unit of a table. Looking into the constraints, we need to maximize the profits. The objective is to maximize the profit. So, how to transform such statement problems into its mathematical equivalent, that is how to perform the mathematical formulation of such problems, is very important, and in this session we are going to understand how to transform the statement problems into their mathematical equivalent. And because there are constraints that the machines can work up to only this much duration, and they can manufacture the product for this many hours or so. So, there are constraints. And constraints, that means you are going to apply the concept of inequalities. That means many a times you need to apply less than or less than equal to or greater than equal to operators to formulate the mathematical equivalent of such statement problems. So, by going through this example, we learned that linear programming is a optimization tool which is many a times required for the problems wherein resource allocation is the prime requirement. It is also applicable to the fields of data science, machine learning and network optimization and many more areas of the computer science. Not only computer science, be it economics or finance or management or any other, in many areas it is very applicable. And in this problem we are supposed to maximize the profits or supposed to minimize the cost. So, the motto is to optimize the objective function, which might be to enhance the profits or reduce the cost. So, this linear programming serves as an efficient tool for decision making, because after performing the calculation it is very simple to take the decision that what should be the rate of production, how much product should be produced. So, by looking at the problem you can understand that linear programming is very much interesting topic and quite applicable into the real life problems. So, here is an example wherein we are representing, this is just an example wherein we are representing how the objective function looks like after its mathematical formulation. Likewise, over here say the objective is to maximize the profits from two products, and wherein x1 and x1 are the quantities of the two products, and the profits on each product is governed by this equation 5x1 plus 7x2, and it is subjected to some constraints, and constraints are represented by the respective inequalities, as I already said, that is less than equal to, less than or greater than equal to. Over here it is x1 plus 2x2 less than equal to 8 and 2x1 plus x2 less than equal to 6. But there is an important observation that product x1 and x2 should always be greater than equal to 0. This is a non-negative negativity constraint, because the products are physical entities and the physical entities can never be negative in nature. So, that is why the products should be greater than equal to 0, and the goal is to determine the values of x1 and x2 to maximize the profits and satisfying the constraints. So, the basic steps of linear programming are to formulate the problem. The first and the foremost important step is to formulate the problem, wherein three sub steps are there, and among them the first one is define the decision variable, define the objective function and define the constraints. Based on the definition of the decision variable, identification of the objective function and constraints, you are supposed to draw the graph and identify the feasible region. Thereafter, from the feasible region it is required to find the optimal solution, and you can use the method like simplex method or graphical method or interior point method to find the optimal solution. We will be exploring the graphical methods. Now, as in the beginning of the session we said that you need to understand the concepts like what objective function is, what is constraint, what is non-negative restriction, what is the feasible region, feasible solution and optimal solution. Here is a set of definitions which are given into your self-learning material also, and the objective function, the formal definition is if a1, a2, a3 up to an are constants and x1, x2, x3 up to xn are the variables, then the linear function z is equal to a1 x1 plus a2 x2 up to an x1 xn is to be maximized. This function z is to be maximized or minimized, and this is function z is nothing but your objective function. Now, what do we mean by constraints? Constraints are actually the restrictions that are to be satisfied by the variables x1, x2, x3 up to xn, and they are expressed by the inequations or inequalities and the equations also. And as I already said, there is a non-negative restriction which says that the value of the variables x1, x2, x3 up to xn which are involved in linear programming problem should always be greater than 0, because these variables represent some of the economic or the physical quantity. Thereafter, what feasible region is, actually this is a common region which is determined by the constraints of the linear programming problem, and this is called also known as feasible region of a linear program. Need not to worry, we are going to apply these concepts when we are going to solve the numerical. In the subsequent slide we are going to understand how to perform the mathematical formulation, how to identify the constraint, how to identify the feasible region, and how to identify the feasible solution. And the feasible solution is actually every point that lies in the feasible region, and it is called the feasible solution. And among the feasible solutions, we need to find the optimal solution, which is a feasible solution that maximizes or minimizes the objective function. So, this was all about the formal definitions about the different concepts like objective functions, constraint, non-negative restriction, feasible region, feasible solution, and optimal solution. Now, we relook at the example which we had given in the beginning, and we are going to formulate this word problem, this sentence problem into its mathematical equivalent. That is, we are going to perform the very first step, that is the formulation of the problem, and in this step we are going to firstly define the variables. Now, since the company is manufacturing chairs and tables, and chairs are x and tables are y, so the variables are x and y. So, firstly we need to focus on x and y, and it is given that chair gives a profit of rupees 20 and tables gives profit of rupees 30. So, the objective function for profit is to maximize 20x plus 30y, where x represents the chairs and y represents the tables, and rupees 20 and 30 are their respective profits which are given by table and chair. Now, we need to formulate the constraints. The constraints are about the 3 machines M1, M2 and M3, and the chair requires 3 hours on machine M1 and table requires 3 hours on machine M1, and M1 can work only for 36 hours per week. So, the constraint, the first constraint is to write 3x plus 3y should be less than equal to 36, because 3 hours are required by table. So, this is, and 3 hours required by the chair on machine M1. So, 3 hours are required by chair plus 3 hours are required for table. So, that is 3x plus 3y, and machine M1 can work at the most of 36 hours per week. So, this should be less than equal to 36. So, I hope you understand that how we transformed the given statement problem into its mathematical equation. This is our objective function, x and y are our variables, and this objective function is to maximize the profits. So, that means we are given the variables x and y are the tables, chairs and tables which are to be manufactured per week. So, the profit of the company will be given by the equation 2x plus 20x plus 30y, and the objective of the company is to maximize the profits. The maximum possible value of the profit is given by P is equal to 20x plus 30y, and this is nothing but our objective function. So, objective function is P is equal to 20x plus 30y. Now, as we had also discussed that there are 3 machines M1, M2 and M3. For machine M1, it takes 3 hours for the manufacturing of the chair, and 3 hours for the manufacturing of the table, and the machine M1 can only work for 36 hours per week. So, this should be less than equal to 36. Similarly, we are having machine M2, wherein the statement it was given that it takes 5 hours to manufacture a chair and 2 hours to manufacture a table by machine M2, and machine M2 can at the most work for 50 hours per week. So, this should be less than equal to 50. Further, it was given that it took 2 hours to manufacture a chair on machine M3 and 6 hours to manufacture a table on machine M3, and machine M3 can work at the most 60 hours per week. So, this should be less than 60. So, these three inequalities are representing the constraints, and there is a non-negativity constraint that chairs and tables can never be negative. So, they can be greater than equal to 0. So, these all are the constraints, So, that means we learned that how to formulate in the problem. The overall problem formulation appears like this, wherein we need to maximize the objective function p is equal to 20x plus 35 subject to these constraints. These are the constraints from machine M1, M2 and M3, and this is the non-negativity constraint. So, I hope you learned how to formulate the problem. Now, let us understand how to find the feasible region or the solution space. Now, before proceeding to find the solution space of the feasible region, let us look at the objective function. The objective function is given to us as 20x plus 30y. And when we were discussing about the equations of line in 3-dimensional geometry, in the session we learned that there is the equation of line y is equal to mx plus c. When we were discussing, just to remind you, when we were discussing about the vector equation of line and Cartesian equation of line, parametric equation of line, it was discussed that there is an equation of line y is equal to mx plus c, and we discussed that complexity of y is equal to mx plus c is on the higher side. That is why parametric equation of lines are given the importance. So, rearranging the objective function p is equal to 20x plus 30y, you can always say that 30y is equal to you can say that 30y is equal to minus 20x plus p, or y is equal to minus 20 by 30x plus p by 30. So, that is equal to y is equal to minus 2 by 3x plus p by 30. So, this is the equation of the line which is to be followed, and and the thing is we are going to have different values of x and different values of y, and but the slope of each and every line will be fixed, that is minus 2 by 3, and we are supposed to find the value of p for which the profit is maximum. So, that means for any particular value of p, we draw the objective function as a straight line, because this is only the objective function which is reformulated into this expression, and the slope of line is minus 2 by 3, and this implies that p is equal to 20x plus 30y is a straight line, and which is rewritten into this format, and we need to find the value of p for which the profit is maximum. How to do this? Let us start. So, firstly we need to find the feasible region. So, in order to find the feasible region, let us take the constraints one by one. Now, in this you are seeing there are different lines, there are 3 lines because there are 3 constraints, and on these lines the equations are written. The first equation is this, This is the first equation. First equation is this. Second equation is this, which is given over here, and third equation is this, which is given over here. And for each equation you are finding that there is a straight line which is intersecting at x axis and y axis respectively, at x axis and y axis respectively. Now, what are the points of intersection? How to find these points of intersection for respective equations or the constraints 1, 2 and 3. So, referring to equation number 1, referring to constraint number 1, that is 3x plus 3y less than equal to 36. By substituting x is equal to 0 in this equation, you will get 3y less than equal to 36, that is y is less than equal to, for the sake you can replace the inequality part with the equality part. That means you can rewrite, to find the point of intersection, you can rewrite the inequality, that is 3x plus 3y less than equal to 36 as 3x plus 3y is equal to 36. Substituting x is equal to 0, you will get 3y is equal to 36, that means y is equal to 36 by 3, that is equal to 12. So, that means y axis is 12, which is given over here, and this point is 12, which is written over here, and for this equation, this is equation number 1. Similarly, if we put y is equal to 0, then you will get 3 into x plus 0 is equal to 36, that is x is equal to 36 by 3, that is equal to 12. So, for the first constraint you will get on x axis 12 value and on y axis 12 value, and this is for first equation, this is 12, this point is 12. So, joining this point with this point, you will get this line. I hope you understand how we determined the point of intersection, that is the intercept on x axis and intercept on y axis, which turns out to be 12 and 12, and we joined the line 3x plus 3y is equal to 36, and this line which is shown in red color is determined. Similarly, repeating the process for other inequalities, that means for the second inequalities, by substituting x is equal to 0 first or y is equal to 0 first, we can get the respective intercepts. Likewise, over here substituting 5x plus 2y is equal to 50. So, substituting y is equal to 0, you will get 5x is equal to 50, that means x is equal to 10. Similarly, substituting x is equal to 0, you will get 2y is equal to 50, that means y is equal to 25. So, y is equal to 25 and x is equal to 10, and this is equation number 2, this is constraint number 2. So, you now you connected these 2 points and you got this line segment, I hope you understand how we got the point 25 and 10 by solving the second constraint. Similarly, you can solve the third constraint and you will get the point of intersection, that is the intercept on the third line, which is a 2x plus 6y, which is your third line, and for this you have got the y intercept as 10 and x intercept as 30. So, we got these 3 constraints, and based on the constraints we are having the 3 types of lines. Now, second observation is to watch at the sign. Now, for the first equation it is less than equal to, for 3x plus y, just recall when we were understanding inequalities, that how we graph the inequalities, how we identified the region that is to be taken care of. So, likewise over here 3x plus y is less than 36, so it is to be given by this region. Similarly, 5x plus 2y is less than 50, so again you are going to get this region. and 2x plus 6y is less than 60. So, 2x plus 6y less than 60, to again you are getting this region. So, all are getting into this region. So, the intersection of all these three region will be wherein all these three lines are appearing is only this region. So, this is the feasible region. So, now in this feasible region you are having this as a point, this is also a point, and this is also a point, and this is also a point. So, these four are the vertices, wherein this point is 0 comma 10, this point is 3 comma 9, this point is 26 over 3 10 comma 3, 10 upon 3, and this point is 10 comma 0. So, we got 4 vertices which are enclosing the feasible region, and this is the feasible region wherein all 3 lines, that is all 3 constraints are contributing. Now, among all 3 points, now your question might be that okay, we got this point that is intercept on y axis as 0 comma 10, and we got this point as intercept on x axis as 10 comma 0, but how we determined this point and how we determined this point? That is how we determined 3 comma 9 and 26 by 3 comma 10 comma 3. Now, in order to understand this, we need to solve the equations, and let me solve it for you for a better understanding. Now, look at this point. This point is intersection of 2 lines, this line and this line. Inequality 2x plus 6y, that means inequality 3, and 3x plus 3y, that is inequality 1. So, this point is in intersection of inequality 1 and inequality 3. So, we need to solve these 2 equations to get the respective value of x and y. How we solve it? Let us see. So, inequality 1 is 3x plus 3y less than equal to 36, or you can write it equal to 36 for determining point x and y, and 2x plus 6y is equal to 60. Now, let us multiply, this is the equation number 1, this is the equation number 2. Multiply equation number 1 with 2 and 2 by 3, you will get answer, you will get equation 6x plus 6y is equal to 72. And multiplying second equation by 3, you will get 6x plus 18y is equal to 180. Now, subtracting 4 from 3, you will get, this will cancel out, and you will get minus 12y is equal to minus of 108. Negative sign will also cancel out, y is equal to 108 by 12, that turns out to be 9. So, the y value is 9, y is equal to 9. I hope you understand how we got y is equal to 9, and y is equal to 9 is just the y coordinate component which is shown at the intersection of the 2 lines, that is this point. Now, how we got x is equal to 3? Substituting y is equal to 9 in any of the equations, they be equation number 1 or equation number 3. So, let us substitute it in equation number 1, y is equal to 9, then you will get 3x plus 3 into 9 is equal to 36. So, that means 3x is equal to 36 minus 27, and that means 3x is equal to 9, x is equal to 9 by 3, that is equal to 3. So, you got x is equal to 3, that means the coordinate is 3 comma 9. So, you got the coordinate this, as 3, 9. I hope you understand how we got the point of intersection. Similarly, you can determine this point of intersection 26 by 3, 10 by 3. Now, it is very important to understand what this equation was all about. We rearrange the equation P is equal to 20x plus 30y, and we got this as the equation of line. This is the equation of line which generates n number of lines with same slope, and the slope is minus 2 by 3. Likewise, over here, this shaded region is the feasible region which we determined in our last slide, and this point is 3 by 9 which we determined, and this is same 26 by 3, 10 by 3. And all these lines, you are seeing these parallel lines are y is equal to minus 2 by 3x plus p by 30. They are moving in this direction because the slope is minus 2 by 3, slope is negative. If the slope is positive, then these lines might have gone in this way, in the rising way, in this direction. But this is decreasing, so it is going in this direction. So that means this equation y is equal to minus 2 by 3x plus p by 30 generates a family of parallel lines with slope minus 2 by 3, but with different intercepts. So these are the intercepts, all of they are intersecting at x axis and y axis. So all are different intercepts along x axis and y axis. So now for any particular line there are different, so that means we are having different combinations of x and y axis. That means x are the chairs and y are the tables. So for every line we are having different combination of x and y. Now which combination of x and y will maximize the profits? So that means as the value of p increases, that means the intercept p by 30 also increases. This is the intercept. So this is as this intercept will increase, that means the profit will increase, and our objective is to maximize the profit. So that means the value of higher value of y intercept yields the higher profits. So that means the problem now resolves to maximize the y intercept. Problem is therefore now to maximize the y intercept. So there are, and we got different points in the feasible region. These are the 4 points which we got in our feasible region, and this point was tan 0, this point is 0 10, this point is 3 9, and this point is 26 by 3, 10 by 3. So all these points are following are lying on different lines. This is lying on this line, this is lying on this line, this is lying on this line. So which line which is all are given by these equations satisfies the maximization of the profits. Now substituting the values, say 3 by 9 into this equation, that is p is equal to 20x plus 30y, you will find that the profit turns out to be, so that means this is representing the intercept p. So maximizing this, so evaluating this value of p which is given by the equation 20x plus 30y at different points, this, you can find that at which point it is maximum. So at point 3, 9, if we put x is equal to 3 and y is equal to 9, you will get 20 into 3 is 60 and 9 into 3 is 270, that turns out to be 330. But it was said that higher the intercept and higher will be the profits. So you might say that at this point is quite lower than this point. 3 9 is lying, the intercept is the value of 9 is lower than this, so the profit should be maximum at 0 10. So if we put the value 0 10 into this equation, that is 20x plus 35y, you will find that profit is equal to 20 into 0 plus 30 into 10, that is equal to 300. which is less than 330. So, these are the feasible solution, point A, B, C and this point D are the feasible solutions, but the optimal solution is given by point B, where the profit is maximum and it turns out to be rupees 330. That means by manufacturing 3 chairs and 9 tables, the maximum profit can be achieved. I hope you understand how to solve a linear programming problem. In this session, we learned how to transform a statement problem given in the statement form into its mathematical equivalent, wherein we understood what is objective function, how to formulate an objective function, how to formulate the constraints, what is a non-negativity constraint, and by solving these constraints, how to find the feasible region. Thereafter, how to find the feasible solutions, and among the feasible solutions, how to determine the optimal solution. And need not to say this applications of linear programming are existing in business, economics, manufacturing, transformation, network flow optimization, resource allocation, machine learning, data science, computer vision, cryptography, data mining, feature selection and game theory, graph theory, artificial intelligence and even optimization of software engineering. So, I hope you enjoyed this session, and the understanding of this session will be extended to other session again, wherein we are going to solve some more problems of the linear programming and understand the concept of cost minimization also by using the concept of linear programming. I again advise you to go through the self-learning material, apply more and more, try more and more questions over there and get the better understanding of the subject. Thank you.